All right, let's dive straight into this explainer. Look, if you've been tracking the massive shifts in tech lately, you already know AI is moving at literally lightning speed. But, there's a huge difference between the AI we were playing with just a year ago and the systems being built right now. Today, we're going to unpack exactly how modern AI is evolving from a simple, isolated brain into a fully autonomous agent. We've got some fascinating ground to cover today. Here's the roadmap. We're looking at the limits of LLMs, compound AI systems, how RAG gives AI a memory, the magic of embeddings, and finally, the era of AI agents. Starting off with Section 1, the limits of LLMs, or, as we're calling it, breaking the illusion of the brain in a box. So to really appreciate where AI is headed, we kind of need to shatter an illusion first. Think about the core software running a standard model. Can an LLM inherently connect to a live weather sensor? Can it tell you who won an election today? Or, I don't know, trigger a physical action like turning off your smart lights? Well, the answer to all of those is a hard no. And that's because a basic LLM is really just a brain locked in a box. It's incredibly smart, absolutely, but it has literally no hands to interact with the world, no windows to see what's happening outside right now. It's completely isolated. And the reason for that isolation? It's bound by its training cutoff date. The source material gives this great example. If an LLM finishes its training on December 24th, it knows absolutely nothing about December 25th. Zero. It only has historical data. And that is exactly why we have to build bridges to the outside world if we want these models to be truly useful. Which brings us to Section 2, Compound AI Systems, equipping the brain with tools. So if the LLM is that isolated brain, compound systems are how we give it eyes, ears, and hands. A standard chatbot actually uses a compound AI system. You aren't just talking to a raw LLM. You're interacting with an LLM that has things like search engines, web browsers, and API callers bolted onto it. The LLM is basically the central reasoning engine, but it relies entirely on those other tools to go fetch today's news and bring it back. Notice the specific tools you actually need to add here to make it useful. Want the weather? You attach a weather API. Needed to write and test Python code? You give it a code sandbox. The LLM just acts like the manager, figuring out which tool to use, but those external systems are the ones doing the heavy lifting. To give you some context, think about standard predictive tech, like analyzing historical sales data to guess next week's inventory. That's discriminative AI. It looks at a pattern and classifies it. But our modern compound systems, they rely heavily on generative AI. It's a fascinating setup where two models actually work together. You've got a generator creating new things and a discriminator checking its work for mistakes over and over again until it can synthesize a perfect brand new response from scratch. All right, Section 3, RAG, giving AI a memory, organizing the scattered papers. Now, here's the big question. How do we feed a company's private external data into this whole setup? Say you have custom pricing plans you want your AI to know about. That is where RAG comes in. The source material uses a brilliant analogy for this. Imagine you have a desk just covered in scattered papers, and every time someone asks a question, you have to frantically dig through the mess. RAG is like an incredibly fast filing cabinet. Instead of throwing all those scattered papers at the LLM, which would totally overwhelm it, RAG organizes them neatly and then pulls out only the exact piece of paper needed to answer the user. I absolutely love this quote from the source material. Without RAG, finding specific data in an LLM is literally like forcing someone to read a 1,500-page book just to find one sentence. It takes way too long and costs a fortune in compute. But RAG and vector databases, they give the AI the exact page number. It's like saying, go straight to page 1808, boom, the answer is right there. Let's break down this architecture step by step, because it's super elegant. First, the user asks a question. Second, and this is key, before the LLM even sees the question, the system searches our private vector database. Third, it grabs the specific context, like the prices of our software packages, and glues it right to the user's query. Finally, only then do we send that combined package over to the LLM. So now, the brain has the exact context it needs for a perfect response. Moving on to Section 4, the magic of embeddings, teaching AI to think in numbers. Okay, but how does RAG actually search through millions of documents that fast? Well, the source reveals a pretty wild detail. AI cannot read English text. It literally doesn't know what words are. It only processes numbers. So we use something called embeddings to convert every unique word, image, or audio clip into a mathematical vector. To the AI, the word weather isn't a word at all. It's a specific coordinate, a string of numbers. And to find answers instantly, the vector database uses this algorithm called cosine similarity. Since all our words are now just points on a massive mathematical graph, the system literally calculates the physical angle and distance between those numerical vectors, meaning if two concepts are close in meaning, their numbers are mathematically close together. Just look at what happens when you map this out. Words like weather, atmosphere, and cooling get assigned similar numerical coordinates and are placed really close together in that dimensional space. Unrelated words, placed far away. So when a user searches for weather, the system mathematically grabs the nearest numbers in milliseconds. It is an absolute game changer for instant accurate retrieval. Which leads us to our final section, number 5, the era of AI agents. From chatbots to autonomous action. Once you give a brain tools and that lightning-fast mathematical memory, you enter the ultimate phase. This is where things get truly futuristic. Unlike standard compound systems that just sort of wait around for your command to fetch a web page, agentic AI uses frameworks to autonomously think, act, and complete complex objectives on your behalf. You give it a high-level goal, and it decides which tools to use, when to search its memory, and how to execute the steps, all without you holding its hand. If you trace this trajectory, the evolution is crystal clear. 2022 was all about pure, isolated large language models. 2023 saw the massive rise of compound AI systems, plugging those brains into tools. And 2024? That's the era we're entering right now, agentic AI. And it is all driving toward one ultimate goal, AGI, or Artificial General Intelligence, systems that can reason, act, and innovate entirely at human levels. But to actually build these agents, you need a very specific layered tech stack. You need a powerful foundation LLM like a Llama or Gemini. You need orchestration frameworks like LangGraph or CrewAI to map out the agent's logic. You absolutely have to have memory modules, so if you chat with your agent on Monday, it remembers the context the following Sunday. And of course, action tools. The source material actually notes that autonomous shopping agents, AIs that can literally browse the web and buy things for you, are expected to hit the market very soon using this exact stack. So, based on everything we've unpacked in this explainer today, I want to leave you with a thought. If an agentic AI system can independently navigate the web, mathematically recall your exact preferences using vector embeddings, and autonomously execute actions like making a purchase, are we still just building software? Or are we building an entirely new kind of digital workforce? It's definitely something to chew on as this incredible tech keeps evolving. Thanks for joining me on this explainer. Keep exploring, and I'll see you next time.